Hello, good day, and welcome to my class. To start, allow me to ask you this question. What are the common products or food you usually buy in the store or supermarket? Yes, we buy a dozen of eggs or a pieces of eggs. We also buy a liter of oil and we buy a kilogram of rice or a sack of rice. We also buy meat, kilogram of meat. And to our mother or parents or even lola and lolas, they buy medicines, 10 capsules or 10 tablets. Now, what do you think the unit use for the element, a substance, and a compound? Yes, it is the mole. Now, our lesson today is a serious lesson of week 6 in grade 9 science. Let's go. But before we will continue, let us learn first a new set of words for today. The first word is Avogadro's number. Avogadro's number is the number of particles in 1 mole of a substance, and it is equal to 6.02 times 10 raised to 23 particles. Again, Avogadro's number. The next word is mole. The mole has a symbol of MOL, and it is written in small letters. Now, what is mole? Mole is the unit of measurement for amount of substance in the International System of Units. It is defined as exactly 6.02214,076 times 10 raised to 23. Our third word is atomic mass. Atomic mass is the mass of one atom of any element in atomic mass unit. And the fourth one is molar mass. Molar mass is the mass in grams of 1 mole of a substance. Again, we have 4 words to learn today. 1. Avogadro's number. 2. Mole. 3. Atomic mass. And the fourth one is molar mass. Now let's go to our main topic. Now let's go to our main topic, and that is the mole. The mole is a fundamental unit of measurement of substances and can be defined as the number equal to the number of carbon atoms in 12.01 grams of carbon. A mole is the atomic or formula mass of a substance expressed in grams. Techniques for counting atoms very precisely have been used to determine this number to be 6.022 times 10 raised to 23, and this value is called Avogadro's number. Let's go. Continue. Remember that in 1 mole it is equal to 6.022 times 10 raised to 23 particles, and that is for the substance. Now for the element, we have atoms. And then for the molecules and compounds, we will use the unit of molecules. Now remember, 1 mole is equal to 6.022 times 10 raised to 23. Now, in 1 mole of something consists of 6.022 times 10 raised to 23 units of that substance. For example, a dozen of eggs. Okay, the 12 eggs, a mole of egg is 6.022 times 10 raised to 23 eggs. Just like a mole of water contains 6.022 times 10 raised to 23 molecules. Now, for example, how many molecules are there in 4.0 moles of carbon dioxide? To answer this question, remember that 1 mole is equal to 6.022 times 10 raised to 23 particles. So, to continue, using the dimensional analysis approach, you will be able to convert number of moles to its equivalent amount in the number of particles. That is, the 4.0 mole of carbon dioxide be multiplied by 6.02 times 10 raised to 24 molecules divided by 1 mole of carbon dioxide. And it is equal to 2.41 times 10 molecules of carbon dioxide. Okay, do you want to have another example? Yes, there is. Now, let's try this example. How many molecules are there in 2.0 moles of sodium chloride? To compute the number of molecules, let us first write the given value. We have 2.0 moles of sodium chloride and be multiplied by 6.02 times 10 raised to 23 molecules of sodium chloride in 1 mole of sodium chloride. Let's try. So the final answer is 1.20 times 10 raised to 23 molecules of sodium chloride. Now, let's try another one. What if we have the 5.0 moles of magnesium chloride? Let's try to solve it. Okay, let's see if your answer is correct. First, write the given value. 5.0 moles of magnesium chloride multiplied by the Avogadro's number, the 6.02 times 10 raised to 23 molecules in 1 mole of magnesium chloride. So what's your answer? Let's see if we have the same answer. The final answer for this is 3.01 times 10 raised to 24 molecules of magnesium chloride. Meaning, in 2 moles of sodium chloride, we have a 1.2 nt times 10 raised to 23 molecules of it. And for the 5.0 moles of magnesium chloride, we have a 3.01 times 10 raised to 24 molecules of magnesium chloride. Okay, now it's your time to do the task. Try to answer the following problems. How many molecules are there in 10 moles of sulfur dioxide? B. 6.02 moles of calcium chloride. And how many atoms are there in 20 moles of oxygen and 0.50 mole of lithium? Now, please pause this video while doing your task. Now, let's see if your answers are correct. For learning task 1, how many molecules are there in 10 moles of sulfur dioxide? We have 6.02 times 10 raised to 24 molecules of sulfur dioxide. And for 6.02 moles of calcium chloride, we have 3.62 times 10 raised to 23 molecules of calcium chloride. And for how many atoms are there in 20 moles of oxygen? Well, we have 1.20 times 10 raised to 25 atoms. And for the 0.50 mole lithium, we have 3.01 times 10 raised to 23 atoms of lithium. I guess, and I'm sure that you got it perfect. You did a great job. Well done, my students. And now, Teacher Grace saying, thank you for watching. Hope you learned new lesson today. Goodbye.